Number 12. Which of the various particles, so we have alpha particles and beta particles and so on. So let's do alpha, beta, so on. So which of these particles may be produced in a nuclear reaction that are actually nuclei? Okay. So the first thing is, what are all the possible particles that we learn in nuclear chemistry? Now, there's a few of them, right? They named two of them, alpha particles and beta particles. So let's write them down along with a couple of other ones, right? So we have alpha particles, and this will be a good, I guess, refresher if we don't know what our particles are. So we have alpha particles, which are the same as just a helium atom. So just know that there's always going to be three components of any type of notation, right? You have the big lettering, and then you have the two numbers, one on the top and one on the bottom. A alpha particle is a helium, so He. Helium's atomic number is always 2, which means that it's got 2 protons. And the alpha particle specifically is helium-4, which means that you have a total of 4 protons and neutrons altogether. So you have 2 protons, which is the number on the bottom, and then you have 2 neutrons making up the total of 4. Beta particles is the next one that they talk about. Beta particles is just a fancy word for saying electrons. Now, electrons, the notation for electrons, can either be lowercase e, but sometimes you might just see them as B for beta. And if we do color, right, here's the big thing. And then you need those 2 numbers, one on the top, one on the bottom. The charge of an electron or a beta particle is always a -1, so that's why there's a -1 on the bottom. And since electrons or beta particles don't live in a nucleus, right, they have no nucleus, the atomic mass is 0, right? It has no protons and no neutrons. It's just a -1 charge for the electron. But now what other ones? Well, let's do the reverse of a beta particle. The reverse of a beta particle is a positron. Positron. I think I spelled it right. Positron is like an anti-electron. So a positron will have a beta symbol, or you could still put your electron in there, right? And with the 2 numbers, one on the top, one on the bottom, it's just the opposite of what a electron is. So instead of -1, it's going to be a +1. And since it's just an anti-electron, what's the opposite of 0? Well, it's just 0. So that number doesn't change. Let's do 2 more, right? We did electrons, right? There's 3 subatomic particles. There's electrons, and then you got the protons and the neutrons. So let's see what a proton is, right? So let's write down a proton. And a proton, just like all these other ones, have, 2 numbers on the top. And actually, 2 numbers, one on the top, one on the bottom. And let's draw that out. A proton stands for a P. Usually you'll see it as lowercase p, right? And a proton, which we know of in acid-base chemistry, right? We always talked about taking a proton or donating a proton, right? Acids donate protons and bases receive or, accept the protons. Remember back in that chapter, right? We always talked about protons, but in terms of protons, you could also talk about it in terms of hydrogen. A hydrogen is a proton. Hydrogen, is a proton here. So you could say H if you want, right? Or you could say P. And a proton has a charge of a +1. So you could just leave it as a 1 if you want. And if it's just a proton, protons are in the nucleus. So its atomic mass is just going to be 1. Has no neutrons because it's literally just a proton. So either way, if you want to say that this is a P or this is an H, that's fine with me as well. They're the same thing. Now, a neutron. neutron has lowercase n. So let's write that down. And then the two numbers, let's see. What is the charge of a neutron? Well, the charge of a neutron is 0, right? No charge for a neutron. Neutrons are neutral, no charge. And a neutron is in the nucleus, so it has a 1 for its atomic mass, right? Atomic mass is always protons plus neutrons. If you're just dealing with a neutron, you just literally have a neutron. So the top number would be 1. And now, let's see, did I miss any? We got alpha particles, which are helium, beta, which are electrons, positrons, which are anti-electrons. We got the proton, we got the neutron, and let's see, anything else? We could do gamma ray, right? And gamma is like that fancy little Y. So like a gamma particle, we could just say that this is gamma, G-A-M-M-A. Okay. Now, a gamma ray is different from a particle, right? This is the only one that is, in terms of radiation. So when you do write a notation for gamma rays, there should not be any numbers on the top and the bottom. So it doesn't, it has no charge, and it's not a nucleus, right? So it's a 0 on the top as well. And it's just that Y. But once again, this is in its own special little corner because this is radiation, electromagnetic radiation, as opposed to particles. And I think I've listed all the particles that you should know. Definitely the alpha, definitely the beta. Positron is anti-electrons, and then you got the protons and the neutrons. But now, which one out of these are actual nuclei? Now, if we're talking about nuclei, we definitely need to be in the nucleus. And if you are, in the nucleus, you definitely need numbers for your top value, because the top value is the atomic mass, and that's the mass of the nucleus. So in order to be a nuclei, the first thing is you have to have a number for, we'll say a number for your atomic mass, which is the top number. So right off the bat, or maybe I'll just say top number. So right off the bat, anyone that doesn't have a number on the top is automatically out. So electrons, they are not nuclei. Goodbye. Positrons, they're not nuclei, and neither are the gamma rays, right? This is pure radiation. But now the next thing is that if you are classifying a particle as a nuclei, right? This comes from the nucleus. There's one other number that you should have, and you should technically be an element on the periodic table, which means that you should have the number on the bottom. So number for atomic number, which is the bottom number. If you have a number for your bottom, that means that you're going to be an element on the periodic table if you have both top and bottom numbers. So now between alpha particles, protons, and neutrons, let's see. Here's a 4 and a 2, and it's helium. It's an atom. So this is definitely one of the answers. This is a nuclei. And now let's see. 1 on top, 1 on the bottom for a proton. We did say that it was a helium, so that's another nuclei because it's got both an atomic mass and an atomic number. But if we look at neutrons, I do have that number on the top, but I don't have an atomic number. No atomic number. So no atomic number, no nucleus. No atom. Right? If I try to look on the periodic table for an atomic number of 0, not going to be there. But 1 is hydrogen and 2 is helium. So in this case, only your alpha particles and your protons are actually nuclei. All other ones, beta, positron, and neutrons, they're just particles. And gamma ray is specifically radiation, so it's in its own group. But I hope this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel. I look forward to helping you in more questions. And we got memberships for the new school year if you want to become a member to the channel. Thank you so much for everyone who has become a member thus far. You guys are greatly appreciated. Thank you, thank you, thank you. And if you want to be one, go check out the perks. It might help you out. We'll see. But thank you so much. I hope you have a great day, and I'll talk to you soon. Okay, bye-bye.